Our equation for cosine was 2 cosine of pi x minus pi plus 1. So we started with the amplitude, which is the absolute value of a. And since a is 2, the absolute value of 2 is 2. The period was next, which is 2 pi over b. B is pi, making the pi's cancel out, period making it 2. The phase shift is c over b. C is pi, b is pi. They cancel out into 1. So then the vertical translation, which is just d, so it's 1 up. The intervals then are the period over 4, which is 2 over 4, making it 1/2. After that, we then graphed it. First, we numbered the vertical axis of the graph up to 3, just to give us room. Then the horizontal axis. We numbered 4 different intervals, going from 1/2 to 1 to 1.5 to 2, just so we could have the full interval, since it is 2. After that, we made our asymptotes, which were 1 right for the vertical one, making it go up at 1, and then it was 1 up for the horizontal asymptote, making them cross at 1, 1. After that, we plotted our points, the first point being 2 up from the middle asymptote directly on the vertical asymptote. And then we went 1 interval over and down to the mid, directly onto the mid asymptote. Then to the next interval, which was 2 below the mid asymptote. The next interval went right back up to the mid asymptote. And then the next and final interval went up to 3. And that was our cosine graph, amplitude, and everything about it. The equation we were given was negative tangent of pi x minus 3. So the amplitude being the absolute value of a being negative 1, the amplitude equals 1. Period, using the equation pi over b being pi, they cancel out, equaling the period being 1. Phase shift, using the equation c over b, having no c, so 0, the phase shift is 0, meaning the graph will not move right or left from the origin. Vertical shift is just d, and the d of our equation is negative 3, meaning a vertical shift of 3 units down. To find the intervals after this would be the period over 2. The period is 1 over 2, 1/2. That'll be our intervals. So to start graphing, we put our asymptotes first at negative 1/2 and at 1/2. We take the beginning middle point of the graph down 3 units to negative 3. And of course, there's a negative flip over the x-axis, so it'll be inverse from what it normally would be. And so you'd graph the points at 1 up and 1 down from the origin. Just 1 up, 1 over, 1 up, 1 down, 1 over, just like you would for a tangent graph. And that is your first one. And then the second tangent period that you would do would be 1/2 over from the rightmost asymptote, making another asymptote at 1.5. Putting another, repeating all the steps. Of course, 1 up, 1 over, 1 down, 1 over, making your second period of the tangent graph.
So our sine function that we got was 3 sine 4x minus 3. So we start with the amplitude. To get the amplitude, you take the absolute value of the a value, which in this case would be 3. Next, we found the period, which is 2 pi divided by b, which would end up with a period of pi over 2 for us. There is no phase shift for this graph because phase shift c over b, and there's no c value, so there's no phase shift. We also had a vertical translation of down 3. And once you have all that, you can find your intervals by taking your period and dividing it by 4. Now you can start graphing. So, You are going to want to label your y-axis, keeping your amplitude in mind and your vertical translation in mind, so you can make sure that you can fit your graph on there. So once you have all that labeled, you can go ahead and label your x-axis, keeping in mind your period, which we determined earlier was pi over 2, and your intervals, which were pi over 8. So you're going to want to use your go by your intervals until you get to pi over 2, and that will be your label for the x-axis. Once you have that, you can start your graph. Keep in mind, in this problem, we have a phase shift of 0, so you don't have to worry about phase shift. Keep in mind that the amplitude is 3, and it's going to start going up because it didn't flip over the axis. And once you have all that information, you can graph it fairly easily, just keeping in mind where the midline is, which the midline would be at -3, because that is the vertical translation. That's how you graph it. So a good real-life application of sine waves is the model sound, and a lot of music producers and stuff use it as a visual way to see what they're doing. And if I was playing a perfect A440, this is the sine wave that you would see. So the feedback you're hearing could be that. And while like guitar tone is very harmonically complex, it can be broken down in these waves if you want to visualize it that way. You can see the pattern of a cosine wave in certain roller coasters, such as this one. So if you look at the graph and look back at the coaster, you can kind of see how the cosine wave pattern can be found. You can also see the tangent pattern in some turn lanes and roads. Now this isn't obviously repeating because it's not a perfect example, but it's an easy way to visualize it.